Sarah Martinez wiped grease from her hands as the factory alarm pierced through the Nebraska dawn. In 12 hours, she would activate a device that would save 3,000 lives. But right now, she was just trying to fix a broken conveyor belt before her shift supervisor noticed. The Hartwell Agricultural Processing Plant wasn't supposed to be a fortress. Built in 1987 on the outskirts of Grand Island, it processed corn and soybeans for half the Midwest. The facility sprawled across 40 acres of Nebraska farmland, its corrugated steel buildings connected by covered walkways and service tunnels. Sarah had worked there for 6 years, maintaining the complex network of conveyor systems, hydraulic presses, and automated sorting machines that kept America's breadbasket flowing. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. At 31, Sarah possessed the kind of mechanical intuition that couldn't be taught in engineering school. She could diagnose a failing bearing by the pitch of its whine, spot a loose belt from across a warehouse, and jury-rig solutions with whatever materials were within arm's reach. Her colleagues called her the wizard behind her back, not mockingly, but with genuine respect. When the multi-million-dollar German sorting machines broke down, management called Sarah before they called the manufacturer. But Sarah's real passion lay in her basement workshop back home. Every evening after her 10-hour shift, she'd descend into her converted basement where workbenches lined every wall. Circuit boards, servo motors, and half-assembled prototypes cluttered every surface. She was developing an autonomous farming robot, something that could plant, tend, and harvest crops without human intervention. The agricultural revolution of the 21st century, she called it. Patents were pending on 3 different subsystems. That Tuesday morning started like any other. Sarah arrived at 5:47 a.m., 13 minutes before her official start time, coffee in hand and tool belt already fastened. The night shift supervisor, Tom Chen, briefed her on overnight issues. Conveyor line 3 had been making grinding noises since midnight. The hydraulic press in Building C was leaking fluid, and the automated grain sorter kept jamming on foreign debris. "Same old Tuesday," Tom said, handing over his clipboard. "Oh, and corporate's sending some efficiency experts next week, probably looking to automate more jobs." Sarah nodded absently, already planning her repair sequence. She'd tackle the conveyor first. Grinding noises usually meant worn bearings, and those could seize completely if left unattended. The hydraulic leak could wait until afternoon. She'd traced similar issues before to worn O-rings, a 15-minute fix once she located the right replacement parts. By 7 a.m., Sarah was elbow-deep in Conveyor Line 3's drive assembly. The grinding wasn't from worn bearings. Someone had accidentally dropped metal debris into the gear housing, probably a wrench or socket from the night maintenance crew. She carefully extracted the foreign material, a twisted piece of steel that looked like it had been intentionally bent into a specific shape. Curious, Sarah examined the metal fragment under her work light. The bends were too precise to be accidental damage. Someone had crafted this piece deliberately, though for what purpose she couldn't imagine. She dropped it into her pocket and continued the repair. The morning progressed normally. Sarah fixed the conveyor, replaced the hydraulic O-rings, and cleared 17 separate jams from the grain sorter. Each jam revealed more of those strange metal fragments, always different shapes, always precisely bent, always deliberately placed. By lunch break, she'd collected 8 pieces. In the break room, Sarah spread the fragments across a table like puzzle pieces. Her coworker Jake Morrison glanced over from his sandwich. "What's all that junk, Martinez?" "Found these jamming up equipment all morning. Look at the precision on these bends. Someone made these on purpose." Jake studied the pieces. "Maybe some pranksters trying to cause trouble. You know how it is with these temp workers they've been hiring." Sarah shook her head. "This isn't random vandalism. These shapes, they're systematic, like components." She photographed each fragment with her phone, then spent her lunch break sketching their dimensions in her notebook. The pieces varied in size and configuration, but they all shared certain characteristics: specific hole placements, consistent material thickness, uniform edge finishing. Someone with serious metalworking skills had created these components. The afternoon brought more discoveries. Sarah found fragments in Building D's packaging equipment, wedged inside the pneumatic tube system that transported grain samples to the quality control lab, even embedded in the loading dock's weighing stations. Each discovery added another piece to her growing collection. By lunch break, she'd collected 8 pieces. In the break room, Sarah spread the fragments across a table like puzzle pieces. Her coworker Jake Morrison glanced over from his sandwich. "What's all that junk, Martinez?" "Found these jamming up equipment all morning. Look at the precision on these bends. Someone made these on purpose." Jake studied the pieces. "Maybe some pranksters trying to cause trouble. You know how it is with these temp workers they've been hiring." Sarah shook her head. "This isn't random vandalism. These shapes, they're systematic, like components." She photographed each fragment with her phone, then spent her lunch break sketching their dimensions in her notebook. The pieces varied in size and configuration, but they all shared certain characteristics: specific hole placements, consistent material thickness, uniform edge finishing. Someone with serious metalworking skills had created these components. The afternoon brought more discoveries. Sarah found fragments in Building D's packaging equipment, wedged inside the pneumatic tube system that transported grain samples to the quality control lab, even embedded in the loading dock's weighing stations. Each discovery added another piece to her growing collection. By 4 p.m., Sarah had identified patterns. The fragments weren't random. They formed groups, sets of components that clearly belonged together, like disassembled mechanisms scattered throughout the facility. Someone was systematically placing these pieces, but why? And more importantly, what were they supposed to build when assembled? Sarah's shift ended at 6 p.m., but she stayed late to continue her investigation. She traced the fragment locations on a facility map, marking each discovery with a red dot. The pattern that emerged made her stomach tighten. The pieces weren't randomly distributed. They formed concentric circles around the facility's main administrative building, where plant management and corporate visitors conduct business. Something was very wrong. Sarah gathered her collection of fragments and headed home, her mind racing through possibilities. The pieces were too sophisticated for casual sabotage, too precisely manufactured to be waste material. Someone with advanced technical skills was placing engineered components throughout the facility, components that seemed designed to assemble into larger mechanisms. At home, Sarah spread the fragments across her basement workbench under bright LED lights. She measured each piece with digital calipers, noting dimensions and tolerances that exceeded typical industrial standards. These weren't garage shop creations. Someone with access to high-precision manufacturing equipment had produced them. Using CAD software on her computer, Sarah began modeling the fragments in 3 dimensions. As digital representations of each piece appeared on her screen, connections became apparent. Holes aligned across components, mounting points matched between pieces, and structural elements suggested mechanical assemblies far more complex than simple sabotage devices. Sarah worked until 2 a.m., driven by growing concern and professional curiosity. By the time exhaustion forced her to bed, she'd identified 3 distinct subassemblies among the fragments. Each assembly appeared to be a component in a larger system, but a system designed for what purpose? Wednesday morning arrived gray and overcast, with storm clouds building on the western horizon. Sarah arrived at work carrying her fragments in a canvas tool bag, determined to find more pieces and solve the puzzle they represented. But as she pulled into the employee parking lot, she noticed something unusual: twice as many cars as typical for a Wednesday morning shift. Inside the facility, Sarah discovered the reason for the crowd. Corporate management had arrived unannounced, not just regional supervisors, but executives from company headquarters in Omaha. They'd set up a temporary command center in the administrative building, complete with laptops, communication equipment, and security personnel Sarah didn't recognize. Tom Chen intercepted her at the time clock. "Martinez, thank God you're here. We've got problems. Big ones." "What's going on with all the suits upstairs?" "Emergency board meeting. Something about the quarterly reports and efficiency projections." Tom lowered his voice. Word is they're considering shutting down the entire operation, moving production to automated facilities down south. Sarah felt her world shift. 3,000 people worked at Hartwell, not just plant employees, but truck drivers, contract maintenance crews, administrative staff, and support personnel. The facility was Grand Island's largest employer. Closure would devastate the entire community. When? She asked. Nobody's saying officially, but scuttlebutt is they'll announce Friday, give everyone 2 weeks' notice, then start the shutdown process. Sarah's mind immediately went to her collection of mysterious fragments. Someone had been systematically placing precision-engineered components throughout the facility for weeks, maybe longer. The timing couldn't be coincidental. "Tom, I need to show you something." Sarah led Tom to a maintenance closet away from the main floor traffic. She opened her tool bag and carefully arranged the metal fragments on a shelf, explaining how she'd found each piece jamming critical equipment. Tom picked up one of the larger components, turning it over in his hands. "This is machined to aerospace tolerances. See these edge finishes? This came from a CNC mill that costs more than my house. That's what bothers me. Whoever's placing these has serious resources and technical knowledge. They know our facility layout, our equipment specifications, even our maintenance schedules. You think it's connected to the corporate shutdown?" Sarah studied the fragments arranged before them. "I think someone's been planning this for months. Look at the placement pattern. Every discovery was near critical infrastructure, power distribution, communications, structural supports." Tom's radio crackled with a maintenance request from Building F. He sighed and clipped it back to his belt. "We need to report this to security." With what evidence? A bunch of metal scraps that could be explained as manufacturing debris? Corporates already decided to shut us down. They'll assume we're trying to create problems to delay the closure. So what do you suggest? Sarah carefully returned the fragments to her bag. "Give me 24 hours. Let me figure out what these pieces build into. If I'm right about this being sabotage, we'll have real evidence to present." Preparing and narrating this story took us a lot of time. So if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Tom nodded reluctantly. 24 hours. But if you find anything dangerous, we call security immediately. The rest of Wednesday passed in a blur of routine maintenance, punctuated by fragment discoveries. Sarah found components in the steam generation system, the electrical distribution panels, even inside the facility's main communication hub. Each new piece added complexity to the puzzle while confirming her worst suspicions. By evening, Sarah had collected 37 distinct components. Back in her basement workshop, she spread them across multiple tables, grouping pieces by apparent function and manufacturing characteristics. Under magnification, she discovered serial numbers etched into several components, numbers that meant nothing to her but suggested these weren't one-off fabrications. Using online databases, Sarah researched the serial number patterns. After 2 hours of searching, she found a match: military procurement codes. These components had been manufactured for Department of Defense contracts, though the specific applications remained classified. Sarah leaned back in her chair, pieces of the puzzle clicking into place. Someone with access to military-grade manufacturing was systematically placing precision components throughout the Hartwell facility. The timing coincided with the corporation's shutdown announcement. The placement pattern targeted critical infrastructure. This wasn't random vandalism or corporate sabotage. This was preparation for something much more serious. Thursday morning brought an answer she wasn't expecting. Sarah arrived early to continue her investigation, but the employee parking lot was nearly empty. A handwritten sign on the main entrance read, "All non-essential personnel report to Building A for mandatory safety meeting, 6 a.m." Inside Building A, Sarah found nearly 300 confused employees packed into the main conference room. Plant manager Rebecca Walsh stood at the front, flanked by corporate executives and several people Sarah didn't recognize, men in dark suits who carried themselves like security professionals. "Due to recent developments," Walsh began, "we're implementing enhanced security protocols effective immediately. All facility access is now restricted to essential personnel only. Maintenance, production supervisors, and administrative staff will continue normal operations under modified procedures. An employee near the front raised her hand. "What about the shutdown announcement?" One of the executives stepped forward. "There is no shutdown. Yesterday's rumors were based on preliminary discussions that have since been resolved. Hartwell will continue normal operations indefinitely." Murmurs of relief swept through the room, but Sarah felt only growing dread. The corporate story didn't add up. Companies don't deploy security teams and implement facility lockdowns because they decided not to close a plant. Something had changed overnight, something that made keeping Hartwell operational a priority. After the meeting, Sarah found herself among the essential personnel cleared for continued access. She spent the morning conducting routine maintenance while discreetly searching for more fragments. The security teams were everywhere now, monitoring access points and conducting systematic sweeps of each building. Around noon, Sarah made a discovery that changed everything. Hidden inside the main grain elevator's control housing, she found not loose fragments, but a partially assembled device. 3 separate component groups had been connected with precision fittings, creating a mechanism about the size of a shoebox. Cables ran from the assembly to connection points that corresponded perfectly with the elevator's power and control systems. Sarah photographed the device from every angle before carefully disconnecting it from the facility systems. The craftsmanship was extraordinary. Every connection engineered for specific voltages and signal types, every mounting point designed for the elevator's exact specifications. Whoever had built this possessed intimate knowledge of the facility's infrastructure. Back in the maintenance shop, Sarah disassembled the device and cataloged its components. What she found made her blood run cold. The assembly included wireless communication modules, precision timing circuits, and what appeared to be remote activation systems. This wasn't sabotage equipment, it was a trigger mechanism designed to interface with facility operations. Sarah's investigation was interrupted by commotion from the administrative building. Through the workshop windows, she watched additional security vehicles arrive, black SUVs with government license plates. Men in tactical gear established a perimeter around the building, while others escorted officials inside. Jake Morrison appeared in the workshop doorway, his face pale. "Martinez, you need to see this. They've got the whole admin building locked down. Word is some kind of federal investigation." Sarah felt pieces of a larger picture snapping into focus. Military-grade components, federal investigators, enhanced security protocols. The device she'd found wasn't designed for simple sabotage. It was sophisticated enough to interface with multiple facility systems simultaneously. "Jake, I need you to do something for me. Can you access the facility's network monitoring logs from your computer terminal?" "Probably. Why?" "I want to see if there's been any unusual network activity over the past few weeks. Unauthorized access attempts, strange data transfers, anything that doesn't fit normal operations." Jake led her to his workstation in the quality control lab. After logging into the network management system, he pulled up activity logs for the past month. Sarah studied the data, looking for patterns that matched her fragment discoveries. "There," she said, pointing to a series of entries. "Look at these access attempts. Someone's been probing our control systems every night, always between 2 and 4 a.m. when we're running skeleton crews." Jake scrolled through the logs. "These IP addresses aren't from our network. Someone's been accessing our systems remotely." Sarah felt the final pieces clicking into place. The fragments weren't randomly placed. They were components in a distributed system designed to give external parties control over facility operations. The wireless modules she'd found could receive commands from outside the plant. The timing circuits could coordinate simultaneous actions across multiple systems. The trigger mechanisms could activate or disable critical infrastructure on command. Someone had been slowly installing a remote control system throughout the Hartwell facility disguised as random maintenance problems. They now had the capability to manipulate power systems, communication networks, safety protocols, and production equipment from anywhere in the world. But why? What made an agricultural processing plant in Nebraska worth such an elaborate infiltration effort? The answer came from an unexpected source. Sarah's phone buzzed with a news alert. Breaking: Federal Task Force investigating cyber threats to critical food infrastructure. She opened the article and read with a growing alarm. According to the report, intelligence agencies had discovered evidence of foreign actors targeting American food production facilities. The goal wasn't destruction, it was control. By gaining access to processing plants, grain elevators, and distribution networks, hostile forces could manipulate food supplies, create artificial shortages, or contaminate products on a massive scale. Hartwell wasn't just any agricultural facility, it processed grain for half the Midwest. Control of its operations could affect food distribution across 12 states. And if similar infiltrations had occurred at other facilities, coordinated manipulation could destabilize America's entire food supply chain. Sarah realized she was holding evidence of a national security threat. The fragments she'd collected weren't sabotage components, they were pieces of a foreign intelligence operation designed to weaponize America's agricultural infrastructure. Thursday evening, Sarah made a decision that would change everything. Instead of reporting her discoveries to facility security, she drove to the local FBI field office in Grand Island. The night duty agent, Special Agent Diana Foster, initially seemed skeptical of Sarah's story. But when Sarah produced the disassembled device and explained the network access patterns, Foster's demeanor shifted dramatically. "Ms. Martinez, I need you to tell me exactly where you found each of these components." Sarah spread her facility map across Foster's desk, marking every fragment location with precise timestamps. Foster studied the pattern while making notes in a secure tablet. "Have you shared this information with anyone else?" "Just Tom Chen, my shift supervisor, but he doesn't know about the assembled device or the network analysis." Foster leaned forward. "Ms. Martinez, what I'm about to tell you cannot leave this room. You've uncovered evidence of Operation Prairie Storm, a multi-year infiltration campaign targeting American agricultural infrastructure. Hartwell is one of 43 facilities that have been compromised." Sarah felt the room spinning. 43 facilities. Food processing plants, grain elevators, distribution centers, even seed production facilities. The operation's been running for at least 2 years. We've been tracking it for 6 months, but we haven't been able to determine the activation timeline. Activation timeline? Foster's expression was grim. The infrastructure they've installed isn't for intelligence gathering. It's preparation for simultaneous disruption of food production and distribution across multiple states. Economic warfare disguised as supply chain problems. Sarah stared at the fragments spread across the desk. "How long do we have?" "Unknown. That's why your discovery is critical. You found a partially assembled trigger system before it was activated. If we can reverse engineer their command structure, we might be able to prevent the operation entirely." Foster gathered Sarah's evidence into a secure case. "I need you to return to work tomorrow as if nothing has happened. Continue your normal maintenance routines, but document any new discoveries. Don't discuss this with anyone, not your supervisor, not your coworkers, nobody." "What about the security teams at the facility, the federal investigation?" "Cover for our operation. We need to maintain the illusion that we're investigating corporate financial irregularities while we actually map the infiltration network." Sarah nodded, though her hands were shaking. "What if they activate the system before you can stop it?" Foster met her eyes. "Then we'll need someone inside the facility who understands their technology well enough to disable it manually. Someone with the technical skills to build countermeasures." Sarah understood. She wasn't just a witness to this operation, she was being recruited to help stop it. The basement workshop she'd used to develop farming robots would now serve a very different purpose, building the tools needed to save America's food supply from foreign manipulation. As she drove home through the Nebraska darkness, Sarah's mind raced with the implications of what she'd learned. Somewhere in the world, hostile forces were preparing to flip a switch that would disrupt food production for millions of Americans. They'd spent years installing the infrastructure to make it possible, but they'd made one critical mistake. They'd underestimated the curiosity and technical skills of a small-town maintenance engineer who noticed when things didn't belong. Sarah Martinez was about to become the most important person in a conflict she never knew existed, a war fought not with bullets and bombs, but with circuits and code, where the battlefield was America's heartland and victory would be measured in the ability to keep families fed. Friday morning arrived with an unseasonable thunderstorm that knocked out power across Grand Island for 47 minutes. Sarah watched the lightning from her kitchen window while coffee brewed on her gas stove, wondering if the storm was natural or if someone had just tested their ability to disrupt the electrical grid. Her phone rang at 5:23 a.m. Agent Foster's voice was tight with urgency. "We've got a problem. 3 facilities went dark overnight. 2 in Iowa, 1 in Kansas. No communication, no network access, no response from on-site personnel. We think they're running field tests." Sarah felt her stomach drop. What kind of field tests? Unknown, but if they're testing individual facilities, it means they're close to full activation. "I need you at Hartwell immediately. We're setting up a joint command center in the administrative building." Sarah arrived at the plant to find the parking lot transformed. Military vehicles sat beside FBI command units, their satellite dishes and communication arrays creating a temporary base of operations. Personnel in various uniforms moved between vehicles with tablets and secure radios, coordinating what appeared to be a major federal response. Inside the administrative building, the conference room had been converted into a high-tech operations center. Wall-mounted displays showed facility diagrams, network traffic analysis, and real-time status feeds from agricultural facilities across the Midwest. Agent Foster stood at the center of it all, directing teams of analysts and technicians. "Martinez, perfect timing. I need you to brief our technical team on everything you found." Sarah spent the next hour explaining her discoveries to a room full of federal agents, military cyber warfare specialists, and Department of Homeland Security analysts. She detailed each fragment location, demonstrated the assembly process for the trigger device, and walked them through the network infiltration patterns she'd identified with Jake's help. Colonel Patricia Hayes, the military cyber warfare team leader, studied Sarah's facility maps with particular interest. "Miss Martinez, you said you found components in the steam generation system. Can you show us exactly where?" Sarah traced the locations on a detailed schematic. Here, here, and here. All connection points for the main distribution network that feeds the entire facility. "And you found similar patterns at power distribution panels?" "Correct. Every major infrastructure system has been infiltrated. Power, communications, water, steam, even the emergency lighting systems." Colonel Hayes exchanged glances with Agent Foster. "This isn't just about disrupting food production. With this level of system access, they could create industrial accidents, contaminate products, or use the facility as a staging ground for broader attacks." Dr. Elena Rodriguez, a cybersecurity specialist from the Department of Energy, leaned forward. "Miss Martinez, in your professional opinion, what would happen if someone activated all these systems simultaneously?" Sarah considered the question carefully. Total facility shutdown at minimum. But if they coordinated the timing properly, they could create cascading failures, steam explosions, electrical fires, structural damage. The facility processes highly flammable grain dust. A coordinated attack could level several city blocks. The room fell silent as the implications sank in. Agent Foster broke the tension. "Which is why we need to disable their network before they can activate it. Martinez, we've analyzed the device you recovered. Our tech team thinks they can reverse engineer the command protocols, but they need access to more components to map the complete network architecture." "I can find more assembled devices. The pattern suggests they've built trigger points throughout the facility." Colonel Hayes pulled up a satellite image of the plant on her tablet. "We can't risk open searches. If they're monitoring the facility remotely, suspicious activity could trigger early activation. We need a covert approach. Sarah studied the satellite imagery, her mind racing through maintenance scenarios that would provide cover for their investigation. I can create legitimate reasons to access restricted areas. Equipment failures, preventative maintenance, safety inspections. I know every system in this plant. What do you need? Access to the facility's maintenance database and authorization to implement emergency repair protocols. If I can justify systematic inspection of critical infrastructure, I can map their entire network without raising suspicion. Agent Foster nodded to a technician at one of the workstations. Give her administrative access to all facility systems. Over the next 4 hours, Sarah orchestrated a masterpiece of deception. She filed maintenance reports for non-existent equipment failures that required immediate inspection of precisely the areas where she expected to find infiltration hardware. She scheduled preventative maintenance on systems that hadn't been serviced in months, creating opportunities to access normally restricted locations. She even declared emergency safety inspections for areas she suspected contained the most sophisticated components. Her cover worked perfectly. Other employees saw Sarah conducting her normal maintenance duties with unusual thoroughness, exactly the kind of behavior they'd expect during a federal investigation. Meanwhile, she systematically mapped the infiltration network, photographing devices, documenting connection points, and building a comprehensive picture of the attack infrastructure. By early afternoon, Sarah had located 12 fully assembled trigger devices and identified the central coordination hub, a sophisticated command unit hidden inside the facility's main electrical distribution panel. The setup was more complex than anyone had imagined. They're not just controlling individual systems, Sarah explained to the command team. They've created a unified network that can coordinate actions across the entire facility. Look at these connection diagrams. They can simultaneously manipulate power distribution, process controls, safety systems, and communication networks. Dr. Rodriguez studied Sarah's documentation. This level of integration suggests they had inside help during installation, someone with detailed knowledge of facility operations and authorized access to restricted areas. Agent Foster's expression darkened. We've been investigating that possibility. Background checks on all employees with facility access, financial records, travel patterns, communication monitoring. So far, we haven't identified any obvious collaborators. Maybe they didn't need a willing collaborator, Sarah said quietly. Look at the installation timeline. These devices were placed over several months, always during periods of routine maintenance or equipment upgrades. Someone could have compromised our supply chain, infiltrated components into legitimate equipment deliveries. Colonel Hayes leaned forward. Explain. Sarah pulled up procurement records on her laptop. 3 months ago, we received replacement parts for the grain elevator control systems. 2 months ago, new communication modules for the facility network. 6 weeks ago, upgraded power distribution components. Every major delivery corresponds to your infiltration timeline. The room buzzed with activity as analysts began cross-referencing procurement records with component placement patterns. Within an hour, they'd traced the infiltrated equipment back to 3 different suppliers. Companies that appeared legitimate but showed signs of foreign financial backing when subjected to deep investigation. Supply chain infiltration, Agent Foster muttered. They've been shipping weaponized components disguised as legitimate industrial equipment for months, probably targeting dozens of facilities simultaneously. Sarah's discovery had revealed not just the local threat to Hartwell, but the methodology being used against the entire American agricultural infrastructure. However, her investigation had also triggered something unexpected. The facility's internet connection suddenly went dead, followed immediately by the cellular network. "They're jamming us," Colonel Hayes announced, checking her secure communication device. "Local communications blackout. They know we're here." Agent Foster grabbed her radio. "All units implement Communications Protocol Alpha. We're operating under electronic warfare conditions." Sarah felt a chill of realization. If they're jamming communications, it means they're preparing to activate the network. The blackout prevents us from coordinating with other facilities or calling for external support. "How long do we have?" Dr. Rodriguez asked. Sarah studied the trigger device schematics she documented. The timing circuits I found were configured for coordinated activation. If they're implementing a communications blackout as a precursor, I'd estimate 30 to 60 minutes before they flip the switch. Colonel Hayes was already issuing orders to her cyber warfare team. Initiate countermeasures. I want every infiltration device mapped and isolated within the next 20 minutes. But Sarah was thinking beyond defensive measures. She'd spent the entire day documenting the attack network, understanding its architecture, analyzing its vulnerabilities. The infiltrators had created a sophisticated system, but like any complex technology, it has weak points. Colonel, what if we don't just disable their network? What if we turn it against them? Agent Foster looked up from her tactical display. What do you mean? Sarah moved to the whiteboard and began sketching a diagram. Their command network has centralized control through the hub I found in the electrical panel. If we can access that hub and reverse the command protocols, we could use their own infrastructure to trace back to their control center. That's extremely dangerous, Dr. Rodriguez warned. If you miscalculate the timing or make an error in the protocol reversal, you could trigger the very attack we're trying to prevent. Sarah met her eyes. If we don't try, they'll activate the system anyway. But if we succeed, we don't just save Hartwell. We identify their entire operation and protect every other facility they've infiltrated. Colonel Hayes studied Sarah's diagram. You're talking about offensive cyber warfare using improvised equipment against an unknown adversary. The risk assessment is irrelevant, Sarah interrupted, because in 40 minutes, they're going to destroy this facility and potentially kill thousands of people. The risk of doing nothing is greater than the risk of fighting back. Agent Foster checked her watch. Martinez, what do you need? Sarah was already moving toward the door. Access to my workshop and 30 minutes of uninterrupted time. I'm going to build something they won't expect. As Sarah headed for the parking lot, her mind was already working through the design requirements. She needed to create a device that could interface with the infiltration network, reverse engineer the command protocols in real time, and redirect the attack back to its source. It would require everything she'd learned about industrial control systems, network architecture, and precision engineering. But as she reached her truck, Sarah realized she faced a fundamental problem. The infiltrators had spent months installing their attack infrastructure using military-grade components and sophisticated planning. She had less than an hour to build countermeasures using whatever materials she could find in a basement workshop. The odds were impossible, the timeline was absurd, and failure would result in catastrophic consequences for thousands of people. Sarah Martinez had never felt more alive. She drove home through the storm with lightning illuminating the Nebraska sky, knowing that somewhere in the world, hostile forces were preparing to flip a switch that would turn America's agricultural infrastructure into a weapon. But they'd made one critical miscalculation. They'd chosen to attack a facility maintained by someone who viewed impossible engineering challenges as personal invitations. In her basement workshop, surrounded by the tools and components she'd collected over years of tinkering and innovation, Sarah began building the device that would either save American agriculture or trigger the very catastrophe she was trying to prevent. The clock was ticking, but Sarah Martinez was ready to build a miracle. Sarah's basement had never felt smaller. Components scattered across every workbench as she raced against a countdown that existed only in her mind. 28 minutes to build a device that could hijack a military-grade infiltration network and reverse its attack protocols. 28 minutes to save thousands of lives with spare parts and determination. She started with the core processing unit, a single-board computer she'd originally purchased for her farming robot project. Its specifications were modest compared to the sophisticated hardware she documented at the facility. But it had one crucial advantage. I understood every circuit, every capability, every limitation. In a time-critical situation, familiar technology beats superior specifications. While the computer booted, Sarah began assembling interface hardware. The infiltration network used proprietary communication protocols, but all digital systems share common underlying principles. Voltage levels, signal timing, data encoding, these fundamentals transcend specific implementations. She could build a universal translator that would adapt her simple computer to communicate with their complex network. Sarah's hands moved with practiced precision, soldering connections and configuring circuits while her mind calculating protocol possibilities. The infiltrators had used military-grade encryption, but they'd also needed their system to interface with standard industrial equipment. Somewhere in their security architecture was a compromise, a translation layer that converted encrypted commands into simple control signals. Her phone buzzed with a text from Agent Foster. Facility sensors detecting unusual electromagnetic activity. They're powering up their network. How much time do you need? Sarah glanced at her partially assembled device. 15 more minutes for hardware. I need 5 for testing. Then we will find out if this works. She didn't mention the real challenge. Even if her hardware functioned perfectly, she still needed to crack their command protocols in real time while connected to a hostile network. It was like trying to defuse a bomb while the timer was running, except the bomb was also trying to reprogram itself to explode faster. Sarah's breakthrough came from an unexpected source. While configuring her interface circuits, she remembered something from her original fragment analysis, the precision tolerances that had bothered her from the beginning. Military-grade components built to aerospace standards, yet designed to interface with agricultural equipment that operated on much looser specifications. That mismatch was their vulnerability. Industrial systems prioritized reliability over security. They used simple, robust communication protocols that had remained unchanged for decades because they worked. The infiltrators had been forced to accommodate these legacy systems, which meant their sophisticated encryption eventually had to be translated into plain text commands that any industrial engineer could understand. Sarah modified her device to intercept those plain text commands before they reached the facility systems. Instead of trying to crack military-grade encryption, she would capture the decrypted instructions at the moment they were converted for industrial use. It was like reading someone's mail by intercepting the translator instead of breaking the original code. 18 minutes after entering her workshop, Sarah had assembled a device that looked like a cross between a laptop computer and an electronic toolbox. Cables snaked between circuit boards, LED indicators showed system status, and a small display provided real-time analysis of network traffic. It wasn't pretty, but engineering elegance was a luxury she couldn't afford. Sarah loaded her device into her truck and raced back to Hartwell through streets now patrolled by military vehicles. The communications blackout had expanded beyond the facility. Radio stations were off the air, cellular networks were down, and even emergency services were operating on backup systems. Whatever the infiltrators were planning, they were creating a complete information vacuum around their target. At the facility, Sarah found organized chaos. Federal agents coordinated evacuation procedures while military technicians attempting to manually disable infiltration hardware. Colonel Hayes met her at the command center entrance. "Martinez, thank God. We've identified activation signatures at 17 different access points. They're bringing the network on systematically, testing each subsystem before full implementation." Sarah studied the tactical displays showing network activity across the facility. They're being careful, testing individual components to ensure everything functions before the coordinated attack. How long do we have? The best estimate is 12 minutes before full activation. Our teams have manually disconnected some infiltration hardware, but we can't reach the central hub without triggering security protocols that might immediately activate. Agent Foster joined them, pointing to a facility diagram covered with red warning indicators. "We've evacuated all non-essential personnel, but we can't clear the area completely without creating obvious signs of federal response. If they detect large-scale evacuation, they might accelerate their timeline." Sarah connected her device to a tactical workstation and began configuring network interfaces. "I'm going to tap into their command hub remotely. If I can intercept the activation sequence, I can reverse the protocols and trace the signals back to their source." "What's the risk assessment?" Colonel Hayes asked. "If I succeed, we will stop this attack and identify their entire operation. If I fail, I might accidentally trigger immediate activation instead of preventing it." Dr. Rodriguez appeared at Sarah's shoulder, studying the improvised device with obvious skepticism. Ms. Martinez, this equipment wasn't designed for military-grade cyber warfare. You're essentially attacking a sophisticated network with modified hobby electronics. Sarah met her gaze while continuing to type configuration commands. Sometimes the best way to beat sophisticated technology is with simple solutions they didn't anticipate. Their security was designed to prevent attacks from other military-grade systems, not improvised countermeasures built in a basement workshop. Her device completed its network scan and began displaying real-time traffic analysis. Data packets flowed across the screen in patterns that revealed the infiltration network's architecture. Sarah watched the digital signatures, looking for the translation points where encrypted commands became plain text instructions. "There," she said, pointing to a specific data stream. "That's their command distribution hub. It's receiving encrypted instructions from an external source and converting them to control signals for individual facility systems." Colonel Hayes leaned closer. "Can you intercept those commands?" "Better, I can modify them." Sarah's fingers flew across the keyboard as she prepared the protocol reversal software she'd written during the drive back to the facility. "Instead of deactivating their network, I'm going to hijack it. Every command they send will be intercepted, reversed, and redirected back to them." Agent Foster checked her watch. 7 minutes until estimated activation. "How long do you need?" 3 minutes to establish connection, 2 minutes to implement protocol reversal, then we see what happens." Sarah initiated the connection sequence, watching as her simple device established communication with the sophisticated infiltration network. Security protocols challenged her access, but her approach bypassed traditional authentication by mimicking the signal characteristics of legitimate industrial equipment. Her screen filled with intercepted commands as the infiltrators began their final activation sequence. Sarah watched the instructions flow past. Commands to disable safety systems, override emergency shutoffs, manipulate pressure controls, and coordinate simultaneous failures across multiple building systems. "They're not just planning to disrupt food production," Sarah announced to the command center. "Look at these instructions. They're engineering a catastrophic industrial accident that would destroy the facility and contaminate the surrounding area with grain dust explosions and chemical releases." The room fell silent as the implications sank in. This wasn't economic warfare. It was terrorism disguised as industrial sabotage. Sarah activated her protocol reversal software. Instead of allowing the malicious commands to reach facility systems, her device intercepted each instruction, analyzed its intended effect, and generated a reversed command that would be sent back along the network to its source. Commands intended to open pressure valves became instructions to close them. Signals meant to disable safety systems instead activated additional protective measures. Instructions designed to coordinate simultaneous failures became commands for enhanced system monitoring and automatic shutdown procedures. But Sarah's masterstroke was more subtle than simple reversal. Hidden within each redirected command was a data packet designed to map the network path back to its source. Every reversed instruction carried embedded code that would trace the complete command structure, identifying every relay point, every control center, and ultimately the master facility coordinating the entire operation. "Connection established," Sarah announced. "Protocol reversal active. All malicious commands are being intercepted and redirected." On the tactical displays, red warning indicators began shifting to green as facility systems responded to the reversed commands by implementing enhanced safety protocols instead of dangerous overrides. But more importantly, Sarah's tracking software began mapping the infiltration network's complete architecture. "My God," Dr. Rodriguez whispered, watching the network map expand across the display. "Look at the scope of this operation." The traced connections revealed a network spanning 12 states, connecting 43 agricultural facilities to a central command center located, according to the geographic tracking data, in a nondescript office building in downtown Kansas City. Secondary nodes in Chicago, St. Louis, and Denver suggested a coordinated operation involving hundreds of people and millions of dollars in infrastructure. Colonel Hayes was already coordinating with federal task forces in those cities. All units, we have live targets. Initiate simultaneous raids on identified command centers. Priority is preserving electronic evidence and preventing network destruction. But Sarah wasn't finished. Her protocol reversal had successfully prevented the attack on Hartwell, but the infiltrators still controlled similar networks at dozens of other facilities. She needed to expand her countermeasures to protect the entire compromised infrastructure. I'm going to propagate the reversal protocol across their entire network. If I can use their own command structure to distribute my countermeasures, I can protect every facility they've infiltrated. Agent Foster looked concerned. What's the risk? If it works, we save the entire agricultural infrastructure and provide law enforcement with real-time access to their complete operation. If it fails, they might detect the intrusion and activate emergency protocols that trigger immediate attacks on all compromised facilities. Sarah didn't wait for authorization. The stakes were too high and the window of opportunity too narrow. She began uploading her reversal protocol to the intercepted command network, using the infiltrator's own distribution system to spread her countermeasures throughout their entire operation. Across the tactical displays, network maps began expanding. Green indicators replaced red warnings as agricultural installations throughout the Midwest reported normal operations despite attacked attacks. The infiltrator's own network had become the delivery system for its destruction. Her phone rang with a call from Agent Foster's counterpart in Kansas City. We've got them. Federal teams have secured the main command center. 18 arrests so far, and we're seeing evidence of foreign state sponsorship. Your network trace gave us everything we needed. Sarah leaned back in her chair, watching the tactical displays show green status indicators across the entire compromised agricultural network. 43 facilities that had been prepared for coordinated attack were now protected by the very infrastructure that had threatened them. Colonel Hayes approached with a satellite phone. Miss Martinez, I have the Secretary of Homeland Security on the line. She'd like to speak with you personally. Sarah took the phone, still somewhat disbelieving that her basement workshop project had just prevented a national catastrophe. The conversation was brief but clear. Her improvised countermeasures had successfully neutralized the largest cyber attack ever attempted against American agricultural infrastructure. As evening fell over Nebraska, Sarah stood outside the Hartwell facility, watching federal agents dismantle the infiltration hardware she'd spent days discovering and documenting. The attack that could have killed thousands and disrupted food supplies for millions had been stopped by a maintenance engineer who refused to ignore small problems before they became large disasters. Agent Foster joined her in the parking lot. The preliminary investigation suggests this operation took 3 years to plan and implement. They infiltrated supply chains, corrupted procurement processes, and installed attack infrastructure across dozens of facilities. If you hadn't noticed those first fragments. Sarah shrugged, watching technicians remove the sophisticated command hub from the electrical panel where it had hidden for months. I just fix things that are broken. When I found components that didn't belong, I kept looking until I understood what they were supposed to do. The president will want to meet you. There's talk of a Presidential Medal of Freedom. Sarah smiled, thinking of her basement workshop and the farming robot project she'd abandoned to build emergency countermeasures. I just want to go home and finish my real project. There's still a lot of work to do making agriculture more efficient and sustainable. As she drove home through the Nebraska countryside, Sarah reflected on the past week's events. She'd started Monday morning fixing a broken conveyor belt and ended Friday evening having saved American agriculture from foreign manipulation. But in many ways, it had been the same job throughout, identifying problems, understanding their scope, and building solutions with whatever tools were available. The farming robot in her basement workshop could wait another few days. Right now, Sarah Martinez just wanted to sleep in her own bed, knowing that somewhere in Washington, D.C., policymakers were working to secure the food supply she'd helped protect. But tomorrow, she'd be back at Hartwell, maintaining the systems that fed America, ready to notice the next small problem before it became a large disaster. Because that's what engineers do. They fix things that are broken and build solutions that make the world work better. The attack on American agriculture had failed, stopped by a small-town maintenance worker who understood that complex problems often have simple solutions, if you're willing to look closely enough to find them. 6 months after the infiltration network was neutralized, Sarah Martinez stood in a congressional hearing room in Washington, D.C., facing a panel of senators who seemed more interested in political theater than understanding the technical details of what had actually happened. The mahogany-paneled chamber felt surreal after spending years in industrial maintenance environments. But the questions being asked suggested that some lawmakers had learned very little from the near catastrophe. Miss Martinez, Senator Patricia Whitman from Iowa began. Some of my colleagues have suggested that your improvised response to this crisis sets a dangerous precedent for vigilante cyber warfare. How do you respond to concerns that private citizens shouldn't be conducting offensive operations against foreign adversaries? Sarah adjusted the microphone, suppressing her irritation at the question's premise. Senator, I wasn't conducting offensive operations. I was performing emergency maintenance on compromised industrial systems. The fact that those systems had been weaponized by foreign actors doesn't change the fundamental nature of the work. Senator David Chen from California leaned forward. But you did acknowledge that your countermeasures could have accidentally triggered the very attacks you were trying to prevent. Doesn't that suggest a reckless approach that endangers public safety? Senator, every engineering decision involves risk assessment. Inaction also carried risks, specifically the certainty that thousands of people would die when the attackers activated their network. I chose the option with the highest probability of preventing casualties. The hearing continued for 3 hours, with senators alternately treating Sarah as either a national hero or a dangerous amateur who'd gotten lucky. The truth, as usual, was more complicated than either narrative suggested. Sarah had prevented a catastrophe, but the broader implications of the attack were still reverberating through government policy and industrial security protocols. After the hearing, Agent Foster met Sarah in the corridor outside the chamber. "How are you holding up?" "I've had easier conversations with broken hydraulic systems," Sarah replied. "At least those follow logical principles." Foster smiled. "Walk with me. There's something you need to see." They took an elevator to the building's basement, where Foster led Sarah through a series of security checkpoints into what appeared to be a high-tech operations center. Wall-mounted displays showed real-time status feeds from agricultural facilities across the country, network traffic analysis, and threat assessment matrices that updated continuously. "Welcome to the Agricultural Infrastructure Protection Center," Foster announced, established 3 months ago based on your recommendations from the Hartwell incident. "We're monitoring every major food production facility in the country for signs of infiltration or attack." Sarah studied the displays, recognizing many of the facilities from her network analysis during the crisis. "This is impressive, but monitoring isn't enough. You need response capabilities, people who can implement countermeasures when you detect threats. That's actually why you're here." Foster gestured toward a conference room where several people in business suits were reviewing technical documents. "The Department of Homeland Security is establishing a new rapid response team for infrastructure protection. We need someone to lead the Technical Operations Division." Sarah felt a familiar mix of excitement and apprehension. "Agent Foster, I'm a maintenance engineer from Nebraska. I fix conveyor belts and grain sorters. I'm not qualified to run a federal cyber warfare program." "You stopped the most sophisticated attack ever attempted against American agriculture using spare parts and a basement workshop. If that doesn't qualify you, I don't know what would." The offer was tempting, but Sarah had spent the past 6 months dealing with the aftermath of her 15 minutes of national fame. Congressional hearings, media interviews, security briefings, and award ceremonies had consumed more time than she'd spent in her workshops since the crisis ended. She missed the simple satisfaction of diagnosing mechanical problems and building practical solutions. "I appreciate the offer, but I think I can be more effective back home. The real work isn't done in Washington. It's done in facilities like Hartwell by people who understand the systems that keep America fed. Foster nodded, though she looked disappointed. I understand. But keep the offer open. If you change your mind, the position will be waiting. Sarah flew back to Nebraska that evening, watching the patchwork of agricultural land spread out below the aircraft. Somewhere down there, farmers were planting crops that would feed millions of people. Processors were converting raw materials into food products, and transportation networks were moving supplies across the continent. The complexity of the system was staggering. Yet it functioned smoothly because thousands like her made sure the mechanical pieces kept working. Back at Hartwell, Sarah found that life had settled into new routines shaped by the enhanced security protocols implemented after the attack. Access controls were stricter, equipment procurement required additional verification, and federal inspectors conducted regular audits of critical systems. The changes were necessary, but they'd also introduced bureaucratic complications that sometimes interfered with efficient operations. "Martinez, thank God you're back," Tom Chen called out as Sarah entered the maintenance shop Monday morning. "We've got 3 systems down and the federal compliance officer wants documentation for every repair before we can proceed." Sarah reviewed the maintenance requests, recognizing familiar problems that should have been simple fixes. A bearing replacement on conveyor line 7, hydraulic fluid leak in building C, and a jammed sorting mechanism in the grain elevator, all routine issues that would normally take her a few hours to resolve. But now, each repair required completion of federal security protocols, verification that replacement parts came from approved suppliers, and documentation that proved the maintenance wasn't creating new vulnerabilities. What had once been straightforward mechanical work had become exercises in paperwork and bureaucracy.
"Tom, who's the compliance officer?" "Special Agent Marcus Webb from DHS. Seems like a decent guy, but he doesn't understand industrial operations. Keep asking why we can't shut down entire production lines to perform routine maintenance." Sarah found Agent Webb in the administrative building, reviewing facility diagrams while taking notes on a tablet. He was younger than she'd expected, probably fresh from federal training programs, with the earnest demeanor of someone trying to do important work without fully understanding its context. "Agent Webb, I'm Sarah Martinez, Facility Maintenance Supervisor. I understand you have questions about our repair procedures." Webb looked up from his tablet. "Miss Martinez, it's an honor to meet you. I've read all the case files from the infiltration incident. Your technical analysis was remarkable. Thank you. I hear you're concerned about our maintenance protocols." Webb pulled up his notes. "I'm trying to ensure that routine repairs don't inadvertently create security vulnerabilities. The attack methodology involved compromised replacement parts, so I want to verify that current procedures prevent similar infiltrations." Sarah appreciated his diligence, but she could see the problem immediately. Webb was applying cybersecurity principles to mechanical systems, creating verification requirements that were unnecessary for most routine maintenance. "Agent Webb, may I suggest a compromise? What if I walk you through our actual maintenance procedures so you can see how we identify and prevent security issues without disrupting critical operations?" Over the next 2 hours, Sarah gave Webb a comprehensive tour of facility operations, explaining how industrial systems functioned, what constituted normal versus suspicious maintenance requirements, and how experienced technicians could identify signs of tampering or infiltration. By the end of the tour, Webb had a much better understanding of the difference between security-critical repairs and routine maintenance. "Miss Martinez, this is incredibly helpful. I think I can streamline our verification procedures to focus on genuinely suspicious activities rather than all maintenance work." "That would be appreciated. Our goal is the same as yours, keeping the facility secure and operational. We just need procedures that support both objectives." Webb implemented revised protocols that week, creating a system that balanced security requirements with operational efficiency. Routine repairs could proceed with standard documentation, while unusual maintenance requests triggered enhanced verification procedures. It was a practical solution that addressed legitimate security concerns without paralyzing facility operations. But Sarah's most important work that month wasn't fixing machinery. It was completing a project she'd started before the crisis interrupted her life. In her basement workshop, the autonomous farming robot she'd been developing for years was finally ready for field testing. The robot represented everything Sarah loved about engineering: identifying a real-world problem, designing elegant solutions, and building something that made people's lives better. Agriculture faced serious challenges: labor shortages, environmental pressures, efficiency demands that required innovative technological approaches. Sarah's robot could plant seeds with precision spacing, monitor crop development using advanced sensors, apply fertilizers and pesticides only where needed, and harvest mature crops without damaging surrounding plants. It was designed to work alongside human farmers, handling repetitive tasks while allowing people to focus on planning, decision-making, and problem-solving. The first field test took place on a farm outside Grand Island, with Sarah monitoring the robot's performance as it planted a 10-acre test plot. The machine moved methodically across the field, adjusting its planting depth based on soil conditions, spacing seeds according to optimal growth patterns, and recording detailed data about every aspect of the process. "This is incredible," said the farm owner, David Patterson, watching the robot work. "How long would it take you to plant my entire operation with machines like this?" Sarah checked the robot's progress data. "For your 800 acres, about 3 days with proper planning, and precision planting should increase your yield by 15 to 20% compared to traditional methods." Patterson was already calculating the economic implications. "Sarah, I want to be your first customer. How soon can you build more of these?" That conversation led to something Sarah hadn't expected: business opportunities that could transform her from a maintenance engineer into an agricultural technology entrepreneur. Word spread quickly through the farming community about her robot's capabilities, and within a month, she was fielding inquiries from producers across the Midwest. But scaling from prototype to production required resources she didn't have: manufacturing facilities, supply chain management, quality control systems, and business expertise that went far beyond her mechanical engineering background. She needed partners who understood the commercial aspects of technology development. The solution came from an unexpected source. Dr. Elena Rodriguez, the cybersecurity specialist from the Hartwell crisis, called Sarah with a proposition. "Sarah, I've been following your farming robot development. I think there's an opportunity to combine your agricultural expertise with advanced cybersecurity capabilities. Would you be interested in discussing a partnership?" They met the following week at the University of Nebraska's engineering campus, where Dr. Rodriguez had established a research program focused on secure autonomous systems. Her lab was developing cybersecurity protocols for agricultural robots, autonomous vehicles, and other connected devices that needed to operate reliably in contested electronic environments. "The problem with most autonomous systems," Dr. Rodriguez explained, "is that they're designed for benign operating environments. But as the Hartwell incident demonstrated, we live in a world where critical infrastructure faces constant threats from sophisticated adversaries." Sarah studied the lab's research projects, recognizing the connections between her robot development and the broader challenges of securing autonomous agricultural systems. "You're talking about building security into the technology rather than trying to add it later." Exactly. Your robot design is remarkable, but imagine if it incorporated the same security principles you use to defeat the infiltration network. Autonomous systems that could detect and respond to cyber attacks while continuing their primary agricultural functions. The partnership made perfect sense. Sarah had agricultural expertise and practical engineering skills, while Dr. Rodriguez brought cybersecurity knowledge and research infrastructure. Together, they could develop farming robots that were not only more efficient than traditional methods, but also more secure than existing autonomous systems. Over the following months, Sarah split her time between maintaining equipment at Hartwell and developing next-generation agricultural technology at the university lab. The work was challenging in entirely new ways. Instead of fixing broken machinery, she was designing systems that wouldn't break in the first place. The breakthrough came when Sarah applied lessons learned from the infiltration network to her robot's communication systems. Instead of using standard industrial protocols that prioritized compatibility over security, she developed custom communication methods that could verify the authenticity of every command while maintaining the real-time responsiveness required for agricultural operations. "It's like building a conversation system that can detect lies," Sarah explained to Dr. Rodriguez during one late-night development session. "The robot knows what legitimate commands should look like, so it can identify and reject anything that doesn't match those patterns." By the end of the year, they had developed a prototype that exceeded both their original specifications. The robot could plant, monitor, and harvest crops with unprecedented precision, while simultaneously detecting and resisting cyber attacks that would compromise less secure systems. The technology attracted attention from agricultural companies, technology investors, and government agencies interested in securing critical infrastructure. Sarah found herself negotiating licensing agreements, patent applications, and research grants, business activities she'd never imagined while fixing conveyor belts at an agricultural processing plant. But the most satisfying moment came during a demonstration for potential investors at a farm outside Lincoln. Sarah watched her robot work across a field with smooth efficiency, planting crops that would feed families while protecting itself from the kind of cyber threats that had nearly destroyed the Hartwell facility. "Miss Martinez," one of the investors asked, "what's your long-term vision for this technology?" Sarah thought about the question while watching her robot complete another planting row with mechanical precision. "I want to build systems that make farming more efficient, more sustainable, and more secure. Agriculture feeds the world. It shouldn't be vulnerable to the kind of attacks we stopped at Hartwell." As evening fell over Nebraska, Sarah realized that her response to the agricultural infrastructure crisis had led to something larger than just preventing a disaster. She'd discovered a way to combine her practical engineering skills with cutting-edge cybersecurity technology to build solutions that addressed fundamental challenges facing American agriculture. The girl who'd started her career fixing broken machinery had become an innovator developing technology that could reshape how America grows its food. But at its core, it was still the same work: identifying problems, understanding their scope, and building practical solutions that make the world work better. Sarah Martinez had learned that sometimes the best way to prevent disasters is to build systems so robust and intelligent that disasters become impossible. The future of American agriculture would be more secure because someone had taken the time to notice small problems before they became large disasters. 2 years after the Hartwell incident, Sarah Martinez received a phone call that would change her understanding of everything that had happened. She was in her expanded workshop, now a legitimate research and development facility behind her house, when Agent Foster's voice crackled through her encrypted phone. "Sarah, we need to meet. Something's happened that you need to know about, and bring your technical analysis files from the original infiltration network." They met at a truck stop outside Omaha, far from any government facilities or potential surveillance. Foster looked older, more tired than Sarah remembered, with the weight of someone carrying classified information that kept her awake at night. "What I'm about to tell you is compartmentalized intelligence that officially doesn't exist," Foster began, sliding an unmarked folder across the table. "The infiltration network you defeated at Hartwell, it wasn't the primary attack." Sarah felt her stomach drop. "What do you mean?" "It was a decoy, a sophisticated, expensive, time-consuming decoy designed to make us think we'd stopped the real threat." Foster opened the folder, revealing satellite photographs and technical diagrams that looked disturbingly familiar. While we were focused on agricultural facilities, they were implementing an identical strategy against water treatment plants. The photographs showed industrial facilities that looked remarkably similar to agricultural processing plants. Complex networks of pipes, tanks, and control systems that could be infiltrated using the same methodologies Sarah had discovered. But instead of threatening food supplies, compromised water treatment facilities could poison entire metropolitan areas. "How many?" Sarah asked. 67 facilities across 15 states. The same supply chain infiltration, the same precision-engineered components, the same remote activation protocols. But this time, they've learned from our response to Hartwell. Their security is more sophisticated, their network architecture is more distributed, and they've implemented countermeasures specifically designed to prevent the kind of protocol reversal you used. Sarah studied the technical diagrams, recognizing architectural patterns from her original analysis, but seeing evolutionary improvements that addressed the vulnerabilities she'd exploited. They adapted their strategy based on studying how I defeated them. Worse than that, we have evidence suggesting they deliberately allowed us to discover and stop the agricultural network in order to observe our response capabilities. Everything you did at Hartwell was monitored, analyzed, and used to improve their water infrastructure attack. The implications were staggering. Sarah's success at Hartwell hadn't just prevented one disaster, it had educated the enemy about American infrastructure defense capabilities. Her improvised countermeasures had been turned into a training manual for more sophisticated attacks. "How long do we have?" Sarah asked. "Unknown. Intelligence suggests they're in final testing phases, but we don't have activation timelines. What we do know is that your original countermeasures won't work against their improved network. They've specifically designed defenses against protocol reversal attacks."
Foster pulled out additional documents showing technical specifications that made Sarah's blood run cold. The water infrastructure network wasn't just more secure, it was more lethal. Coordinated attacks on water treatment facilities could contaminate supplies for millions of people, create public health emergencies that would overwhelm medical systems, and cause social disruption that would make the agricultural threat look insignificant. "What do you need from me?" Sarah asked. "We need you to do what you did before, but better. Analyze their improved network, identify new vulnerabilities, and develop countermeasures that can defeat securities specifically designed to stop you." Sarah laughed bitterly. "Agent Foster, they've spent 2 years studying everything I did at Hartwell. They know exactly how I think, what tools I prefer, what approaches I'm likely to try. Building countermeasures against an enemy who's had 2 years to prepare for you is like trying to surprise someone who's already read your playbook. Which is why you need to write a new playbook." That evening, Sarah sat in her workshop, surrounded by technical documentation that painted a picture of unprecedented sophistication. The water infrastructure network represented an evolution in cyber warfare that went far beyond the relatively crude infiltration she'd discovered at Hartwell. These adversaries had learned from their mistakes and built something much more dangerous. But as Sarah studied their improved architecture, she began to see patterns that suggested an unexpected opportunity. The sophistication that made their network more secure also made it more complex, and complex systems, by definition, had more potential failure points than simple ones. The infiltrators had designed their security specifically to prevent the countermeasures Sarah had used at Hartwell, but in doing so, they'd optimized their defenses against known threats while potentially creating vulnerabilities to completely different approaches. Sarah spent the next week developing what she privately called asymmetric countermeasures, solutions that attacked the water infrastructure network from directions they hadn't anticipated. Instead of trying to reverse their command protocols, she would target their power management systems. Instead of hijacking their communications, she would interfere with their timing synchronization. Instead of working within their network architecture, she would attack the physical infrastructure that supported it. The key insight came from her experience developing agricultural robots with Dr. Rodriguez. They'd learned that the most effective security came not from building impenetrable defenses, but from creating systems that could adapt to threats in real time. Sarah realized she could apply the same principle to defeating the water infrastructure network. Rather than building a single countermeasure designed to work against their specific defenses, she would create multiple adaptive countermeasures that could modify themselves based on the network's responses. It was like playing chess against an opponent who's memorized your favorite opening moves. You won by playing a completely different game. Sarah's new approach required resources beyond what she could provide from her workshop. She needed access to water treatment facilities for testing, collaboration with municipal engineering departments, and coordination with federal agencies that understood the scope of the threat.
Most importantly, she needed to work in complete secrecy to prevent the infiltrators from observing and adapting to her new methods. The solution came through Dr. Rodriguez's research connections. The University of Nebraska had established partnerships with municipal water departments throughout the region, creating opportunities for testing security systems without revealing the true scope of the threat. Sarah could develop and test her countermeasures under cover of academic research into water infrastructure cybersecurity. Over the following months, Sarah essentially lived two separate lives. During the day, she continued her agricultural technology development, building and testing farming robots that were attracting international attention from investors and agricultural companies. But at night, she worked on water infrastructure security, developing countermeasures for a threat that officially didn't exist. The dual existence was exhausting, but it provided perfect cover for her real work. Anyone monitoring her activities would see a successful agricultural technology entrepreneur conducting legitimate research with university partners. They wouldn't see someone developing weapons specifically designed to defeat their most sophisticated cyber warfare operation. Sarah's breakthrough came during testing at a water treatment facility outside Lincoln. While examining the plant's control systems, she discovered something the infiltrators hadn't anticipated: legacy equipment that predated modern network security protocols. Many water treatment facilities used industrial control systems that were decades old, installed long before cyber warfare became a serious concern. These legacy systems weren't connected to modern networks in ways the infiltrators could easily exploit, but they controlled critical infrastructure functions that newer systems depended on. If Sarah could use these legacy systems as entry points, she could potentially access and disrupt the infiltration network from directions they hadn't considered. It was like finding a secret passage in a heavily fortified castle. The infiltrators had secured all the obvious entrances, but they'd overlooked the maintenance tunnels that connected to the same critical systems. Sarah developed what she called legacy system bridging, techniques for using old industrial equipment to access and influence modern networked systems. By understanding how legacy and modern systems interface, she could potentially bypass the sophisticated security measures designed to prevent network intrusion. But testing the approach required access to actually infiltrated facilities, which meant Sarah needed to identify water treatment plants that had been compromised without alerting the infiltrators to her investigation. The solution came from an unexpected source: her agricultural robot customers. Several of the farms using Sarah's technology were located near suspected water treatment facilities, providing legitimate reasons for her to be in those areas while conducting routine maintenance and support for her robots. Sarah modified her agricultural robots to include sophisticated electronic monitoring capabilities disguised as environmental sensors for crop optimization. While the robots performed their normal farming functions, they also conducted passive surveillance of nearby water treatment facilities, detecting the electromagnetic signatures of infiltrated control systems. Within 6 weeks, Sarah had identified 12 confirmed infiltration sites and mapped their network architecture using data collected by her farming robots. The intelligence was extraordinary. Detailed technical specifications of the water infrastructure network obtained without any direct intrusion that might alert the infiltrators. But the data also revealed the true scope of the threat. The water infrastructure network wasn't just more sophisticated than the agricultural infiltration. It was designed for coordinated activation across multiple metropolitan areas simultaneously. Intelligence suggested they were planning attacks that would affect water supplies for over 20 million people. Sarah realized that her countermeasures needed to be deployed not just at individual facilities, but across the entire infiltrated network simultaneously. The infiltrators had learned to coordinate their attacks, so the defense needed to be equally coordinated. Working with Dr. Rodriguez and a carefully selected team of graduate students who'd been granted security clearances, Sarah developed a distributed countermeasure system that could be deployed across multiple water treatment facilities without requiring on-site installation. Using techniques adapted from her agricultural robot communication protocols, she created countermeasures that could propagate through utility networks and activate automatically when infiltration attempts were detected. The system was elegant in its simplicity. Instead of trying to defeat the infiltration network directly, it would make the network defeat itself. When the infiltrators attempted to activate their attack protocols, Sarah's countermeasures would redirect their commands to trigger safety systems that would shut down affected facilities temporarily, preventing contamination while alerting authorities to the attempted attack. But deploying the countermeasures required Sarah to take unprecedented risks. She needed to physically access infiltrated facilities to install her defensive systems, which meant entering hostile territory where her presence could trigger immediate activation of the very attacks she was trying to prevent. Agent Foster arranged cover through a fictional consulting company that specialized in water infrastructure efficiency audits. Sarah would enter target facilities as a systems analyst conducting routine optimization studies, giving her legitimate access to the control systems she needed to reach. The first deployment took place at a water treatment facility outside Kansas City. Sarah arrived in a rental car with a briefcase full of monitoring equipment, posing as a consultant hired to identify opportunities for energy efficiency improvements. The facility manager, unaware of the true purpose of her visit, gave her complete access to the control systems. Sarah found the infiltration hardware exactly where her intelligence had predicted: sophisticated devices integrated into the facility's power management and chemical dosing systems. But instead of trying to remove or disable the hostile hardware, she installed her countermeasures alongside them, creating a hidden defensive layer that would activate if the infiltration network attempted to implement attacks. The installation required precise timing and careful attention to electromagnetic signatures that might reveal her activities to remote monitoring systems. Sarah worked with the same methodical precision she'd developed maintaining agricultural equipment, but with the knowledge that any mistake could trigger a catastrophic attack on the metropolitan water supply. By the end of the day, she'd successfully installed countermeasures that would protect the facility's 4 million customers from contamination attacks while providing intelligence on any attempted infiltration activities. But Sarah knew that one facility was just the beginning. She needed to repeat this process at dozens of locations across multiple states, all while avoiding detection by sophisticated adversaries who'd spent years preparing for exactly this kind of intervention. As she drove back to Nebraska through the Kansas countryside, Sarah reflected on how far her life had traveled from fixing broken conveyor belts at an agricultural processing plant. She was now conducting covert operations against foreign cyber warfare networks, using skills she'd developed as a small-town maintenance engineer to protect millions of people from threats they'd never know existed. But the work was far from finished. Sarah had identified the scope of the water infrastructure threat and developed countermeasures that could defeat it, but deployment would require months of careful operations across dozens of facilities. And somewhere in the world, hostile forces were preparing to activate attacks that could poison entire metropolitan areas. The race was on, and Sarah Martinez was running out of time to save American cities from an enemy that had learned to anticipate her every move. The call came at 3:17 a.m. on a Tuesday in March. Sarah's encrypted phone buzzed with the emergency tone that meant only one thing: the water infrastructure network was activating. Agent Foster's voice was tense. "Chicago, Denver, and Atlanta are showing activation signatures. We estimate 12 minutes before full implementation. How many facilities do you have protected?" Sarah was already pulling on clothes while calculating deployment status. 38 installations with active countermeasures, 16 more with partial coverage. But if they're coordinating across multiple cities, they might have changed their activation protocols. Can your countermeasures adapt in real time? We're about to find out. Sarah ran to her workshop and activated the monitoring systems she'd built to track her distributed countermeasures across the infiltrated water network. Screens filled with data streams from dozens of facilities as her defensive systems detected the beginning of the coordinated attack. The infiltrators had indeed evolved their approach. Instead of the simultaneous activation Sarah had anticipated, they were implementing a cascading attack, triggering facilities in sequence to maximize disruption while minimizing the defensive system's ability to coordinate responses. But Sarah had anticipated this possibility. Her countermeasures included adaptive protocols that could detect and respond to sequential activation patterns. As each facility came under attack, her defensive systems would learn from the assault and update their responses across the entire network. She watched her screens as the battle unfolded in real time. Chicago's water treatment facilities were the first targets, with infiltration hardware attempting to override chemical dosing systems that could have contaminated supplies for 3 million people. But Sarah's countermeasures activated exactly as designed, redirecting the malicious commands to trigger safety shutdowns that protected the water supply while alerting facility operators to the attempted attack. Denver followed 7 minutes later, then Atlanta, then facilities in secondary cities that hadn't appeared on Sarah's original intelligence reports. The attackers were more widespread than anyone had realized, but her adaptive countermeasures were learning and evolving faster than they could adjust their tactics. "Sarah, we're seeing defensive activation at facilities we didn't even know were compromised," Agent Foster reported over their secure channel. "Your countermeasures are detecting infiltration hardware that our intelligence missed." Sarah's monitoring systems showed successful defensive responses at 43 facilities across 12 states. Her distributed countermeasures had not only protected the installations she directly secured, but had propagated to additional facilities through utility network connections, creating a defensive web that exceeded her original deployment. But the most important data wasn't the successful defenses. It was the intelligence her countermeasures were collecting about the attack network's command structure. Every thwarted activation attempt provided information about the infiltrator's communication protocols, geographic distribution, and operational hierarchy. "Agent Foster, my systems are mapping their complete network architecture in real time. I'm getting traceback data on command centers, relay points, and what looks like their primary coordination facility. Location?" Sarah watched as her analysis algorithms processed the network traffic patterns. "Vancouver, Canada, industrial district near the port, and there's something else. The signal patterns suggest this isn't just about water infrastructure. They've got similar networks targeting power grids and transportation systems." The realization hit Sarah like a physical blow. The water infrastructure attack wasn't an isolated operation. It was one component of a coordinated assault on multiple critical infrastructure sectors. While they'd been focused on protecting water supplies, the infiltrators had been preparing to simultaneously attack electrical power, transportation networks, and communication systems. "Agent Foster, we need to expand the countermeasures immediately. If they're running parallel operations against power and transportation, my defensive systems can be adapted to protect those networks too. How quickly can you implement expanded coverage?" Sarah was already modifying her countermeasure algorithms to detect the signature patterns of power grid and transportation infiltration. 20 minutes to adapt the software, then automatic propagation through interconnected utility networks. But we need to assume they'll attempt immediate activation once they realize their water attack has failed. The next hour became a blur of frantic technical work as Sarah raced to expand her defensive systems beyond water infrastructure. She modified her countermeasures to recognize and respond to power grid infiltration, transportation system attacks, and communication network disruption. The adaptive protocols she'd originally designed for water facilities proved remarkably flexible, automatically adjusting to protect completely different types of infrastructure. By dawn, Sarah's distributed countermeasures had detected and thwarted infiltration attempts at over 200 facilities across 17 states. Power grids in major metropolitan areas had been protected from coordinated blackouts. Transportation control systems had been secured against attacks that could have caused train derailments and highway traffic management failures. Communication networks had been shielded from disruption that could have prevented emergency response coordination. But the most significant victory was the intelligence windfall her countermeasures had collected. The attempted attacks had revealed the complete scope of a foreign cyber warfare operation that spanned multiple countries, targeted dozens of infrastructure sectors, and represented the most sophisticated assault ever attempted against American critical systems. Agent Foster called Sarah with the final assessment as federal agencies coordinated simultaneous raids on command centers identified through her network analysis. Sarah, preliminary reports show we've neutralized command facilities in Vancouver, Tijuana, and what appears to be a coordination center in Eastern Europe. Your countermeasures didn't just stop the attacks, they mapped the entire enemy network and provided targeting intelligence for offensive operations. Sarah sat back in her workshop, exhausted but exhilarated. Her distributed countermeasures continued monitoring protected facilities, but the immediate threat had passed. American critical infrastructure was secure, and the hostile network that had threatened it was being systematically dismantled by federal law enforcement. Agent Foster, there's something else. My countermeasures are designed to remain in place as permanent protective systems. They'll continue adapting and evolving to protect against future infiltration attempts. American infrastructure should be significantly more secure than it was before this attack. The aftermath brought revelations that shocked even Sarah. The investigation of captured infiltration networks revealed that the operation had been in development for over 5 years, involved multiple foreign intelligence services, and represented an investment of hundreds of millions of dollars. The goal hadn't been simple disruption. It had been preparation for a comprehensive cyber warfare campaign designed to cripple American infrastructure during a potential future conflict. Sarah's countermeasures had stopped not just an immediate attack, but had prevented the establishment of cyber warfare capabilities that could have been activated during any international crisis for years to come. 3 months later, Sarah received a call from the President of the United States. The conversation was brief but extraordinary. She was being awarded the Presidential Medal of Freedom for preventing what intelligence assessments now described as the most dangerous cyber warfare operation in American history. But the recognition that meant the most to Sarah came from an unexpected source. Water utility managers, power grid operators, and transportation officials from across the country sent letters thanking her for protective systems they'd never known existed. Families in dozens of cities had been protected from contaminated water, power outages, and transportation disruptions that could have caused thousands of casualties. Sarah realized that her greatest achievement wasn't defeating a sophisticated enemy. It was building systems robust enough to protect people who never knew they needed protection. Today, Sarah Martinez continues developing agricultural technology from her Nebraska workshop, but her distributed countermeasures remain embedded in American critical infrastructure, constantly adapting and evolving to protect against threats that haven't been invented yet. Her farming robots help feed America, while her security systems protect the infrastructure that makes modern life possible. The small-town maintenance engineer who once fixed broken conveyor belts has become the architect of America's infrastructure defense, building solutions that turn technological complexity into national security. And somewhere in her basement workshop, Sarah Martinez is probably working on the next impossible engineering challenge that will keep America safe, one practical solution at a time. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out, and don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.